Hello all, and welcome to Reflections and Rotations that take a shape onto itself, also known, or better known, as symmetry. You probably remember symmetry from grade school. You know, you did the art project, you had a little butterfly, and you had to paint one of the wings, and then you fold it, and then the wet paint copies from one wing to the other wing, in other words, onto itself. That is exactly what I mean. If I reflect this across the middle line, it becomes the exact same shape, even though this point on the left ends up on the right. Still the same shape, still the same orientation, still the same size, still the same everything. So that's what I mean by symmetry. And there are two ways to do this. This reflection symmetry is the first way. We normally say that we reflect across. We can't just say middle, that's not quite accurate enough. We have to use the more accurate words perpendicular bisector. Perpendicular meaning 90 degrees, you probably remember that from a couple lessons ago. Bisector meaning middle, exact middle of a side. In other words, if I have this hexagon, if it was drawn perfectly, because I'm not a perfect artist and I wasn't being careful, I would go find the middle of one of the sides, and I can't just go in any direction I like. I have to go 90 degrees straight up, which happens to be the middle of the opposite side, the perpendicular bisection of the opposite side as well. So I'm really connecting two perpendicular bisectors. Or, some of you probably noticed, you can go across this way. I can go corner to corner, also known as vertex. The vertex, or vertices plural, is the corner of a shape. So I can go vertex to vertex, I can go perpendicular bisector to vertex, or in some cases, like if I have a pentagon which has an odd amount of sides, I can go from the vertex to the perpendicular bisection of the other side. That cuts the shape in half. How many of these lines can I make? Well, that depends on how many sides it has. Normally, it matches. This has 6 sides, so I can do 1, 2, 3, 4, 5, 6 lines. This has 5 sides, so I can do 1, 2, 3, 4, 5 lines. And for most regular shapes, this is true. If the shape isn't regular, isn't the same size and shape, for example, this slanted parallelogram, which is not the same size, angles, shape everywhere, then you may have to draw it out and check, like, I don't see any way to fold this shape in half. Maybe like this diagonally, but that's a stretch. Okay, that is the first way we talk about symmetry. The second way is the one less often thought of, but it's called rotational symmetry. If you're familiar with playing cards, not the Uno kind, actual playing cards, where what you have written up top is written upside down as well, so that way if you turn the card upside down, you can still read what it is. That is rotational symmetry. In rotational symmetry, I take a vertex and I rotate it until it becomes another vertex, and then the shape should look the same. For most shapes, for most regular shapes, I can rotate it the amount for every vertex. So for example, in this square, I can rotate A here, 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 and finally back to the start. 4 rotations, making a complete circle. So how far do I go? Well, a full circle is 360 degrees. I'm doing 4 rotations, which means each rotation is 90 degrees in measure. This first one is 90. The second one is another 90. 90 plus 90 is 180. The third one, add 90 again, and I get 270. The fourth one, add 90 again, and I get back to 360. And this works for any regular shape. If I have 5 points, again, most people don't know this one off the top of their head, but take your calculator, 360 divided by 5 is 72, which means I'm going in multiples of 72. 72 for the first rotation, plus another 72 is 144. For the second rotation, plus again is 216. For the third rotation, plus another 72 is 288 for the fourth, plus another 72 is 360 for the fifth. And I only know that off the top of my head because I've done this a lot. You don't have to. Take your calculator and add 72 plus 72 plus 72 plus 72 plus 72. So what if the shapes are combined somehow? Like what if I had a big square with a pentagon in it? We'll take a look at the numbers we did for each shape. We have to see if any of them match. The only one I see that matches is 360, which means I can only rotate this a full 360 degrees to get back to the beginning. If you see more matches, then there are more ways I can rotate it to get it back to looking like it did. And again, for irregular shapes, like my lovely parallelogram right here, you may have to draw an experiment. This one I can rotate, even though it has 4 sides, I can only rotate it upside down, 180 degrees. There is no other rotational symmetry other than 180, 360. Every shape should have 360 rotational symmetry. Why do you think that is? Because if I rotate a full circle, it's going to go back to normal no matter what. So hopefully with all that information, you should be able to get started on the next mastery test.